Chapter 10 Review, question E51. We have a sample size 23 and a test statistic value of 1.645. So looking at these three sketches, we want to know which one would correspond to the p-value for a two-sided test. With two-sided, we're going to have equal amount of possibility in both tails. So this one only gives the left, this one only gives the right. Figure 2 gives both tails, so for the two-sided test, figure 2 is correct. Which part of the shaded area corresponds to the evidence that mu is greater than the null hypothesis mean? So the null hypothesis population mean is going to be right at the center of any of these distributions. So if we have a test statistic of 1.645, that's a positive value, which means we're to the right of the mean here. Notice that this could also be negative. For example, you can see down here negative 1.645. So the right hand here would correspond to being greater, our sample mean being greater than the hypothesized population mean. If the two-sided p-value is p and the one-sided p-value will be, well, you can see here if we have double, if we have two places basically to reject the null, and then we take away one of those, we're only going to have half as much. So this would be p divided by 2. And finally, all else is equal, alternate hypothesis in the right direction, will the p-value be larger for a one-sided test or a two-sided test? So given that we start off with some test statistic and we want to know what the p-value for that particular test statistic is, if we're splitting up like this, we're splitting up the critical rejection region, then because we split it up, the given t-value isn't going to have as high of, or it isn't going to have as strong of a p-value, as low of a p-value. However, if we don't split it up, if we just have a one-sided test, we put the entire region that we're looking at. In other words, you can think of taking away this shading and adding it right here, then we're going to have a greater chance of rejecting, and so that p-value is going to be larger for the two-sided. In other words, it's stronger for the one-sided. We're more likely to reject with the one-sided because a larger p-value typically is not what you want. You typically want the smaller p-value, assuming that you're trying to reject the null hypothesis.